Hi everyone. So this is going to be week 5 and 6, also known as, but we're on week 4, but it's just going to cover week 5 and 6 on our syllabus. So this topic is going to be the official language of chemistry, also known as nomenclature. Sorry, I put too much space over here. Nomenclature, or simply naming compounds. So we have two different rules for nomenclature. We have rules for covalent compounds, and we also have rules for ionic compounds. We're going to go ahead and start with our covalent compounds. So just briefly, I'm going to go ahead and review like what covalent compounds are. It's going to be compounds that share electrons in things like single, double, and triple bonds. And they're also going to be two nonmetals. So the rules for naming covalent, so each time you see nomenclature, just replace it with naming. So the rules for the chemical naming of covalent compounds is going to be, first, we always use prefixes to show the number of atoms. So if we have something like CO2, we're going to use the prefix of di to show the number of oxygens that we have, because we have two oxygens. So we're going to use the prefix of di. The first element keeps its full name. So the first element is going to keep its full name. It's going to be something like, so in the instance of CO2, it's going to be just carbon. So full name. But the second element in CO2 is going to change. So we have carbon, which is the first element, keeping its full name. But the second element ends in "ide." So to bring this rule together, oxygen, the prefix, we need to use a prefix to show the number of atoms. Carbon has 1. Oxygen has 2. Let's go ahead and say monocarbon. And then the next thing is going to be the prefix for 2 oxygen is going to be di. And it's not going to be, you might be thinking it's going to be something like dioxygen. But like the third rule states that the second element ends in "ide." So instead of ending in oxygen, we're going to go ahead and delete this, and it's going to be dioxide. And then if we look at our fourth rule, we don't use mono on the first element. So I'm gonna go ahead and just delete this, and it's going to be, the entire thing is going to be carbon dioxide. And that's going to be the naming of covalent compound CO2. Both of these are two nonmetals, and they share electrons if we draw their Lewis structures. Okay, so another example to bring this together is going to be, I'm going to go ahead and get a sticker. Is going to be NO2. So NO2, how do you say NO2? So we're going to go ahead and go to the process. First, we're going to use prefixes to show a number of atoms. So we have N, which has 1, and then oxygen, which has 2, which is 2 oxygens. N1, that's the first element. Nitrogen is going to be the first element, but it's going to keep its full name, so it's not going to end in "ide" or anything like that. And then the fourth rule states that don't use mono on the first element, so it's going to be nitrogen. And then if we look at our second element, we have oxygen. But it's going to be 2 oxygens, so we're going to write di as their prefix. And then also the second element always ends in "ide", so we're just going to delete the the igen, and it's going to end like this, and it's going to be nitrogen dioxide, and that is how you name NO2. And if we look at over here, that is correct. Okay, so our next practice is going to be PCl5. So we have phosphorus, which is 1 atom, and we have Cl5. We have chlorine, which is 5 atoms. So we're going to go ahead and start with phosphorus. If we look at phosphorus, we see that it's the first element. It only has it's only 1 atom. So we're going to, you might be thinking monophosphorus, but our 4th rule states don't use mono on the first element. So it's going to be phosphorus. And then it's going to be, we're going to have to use a prefix to show the number of atoms for chlorine, because chlorine is 5. If you look at our table over here, it's going to be penta. So it's going to be penta. And then it's going to be chlorine. But it's going to end as chloride. So it's going to be pentachloride. So the entire name is going to be phosphorus pentachloride, which represents PCl5. Okay, so we have some other practices over here. We have SO3, CO, N2O, CCl4. We're going to go ahead and do them real quick just to practice. So our first one is going to be SO3. So we have sulfur, and we're just going to go ahead and write the full name because the first element, it doesn't end with "ide" or anything like that. And it also is only 1. So, but it's not going to be monosulfur because it is going to be the first element. And then we look at our second element, which is going to be oxygen, and it has 3. Oxygen has 3. It's 3 oxygens. So we're going to use the prefix tri to represent 3 oxygens, and then we're going to do ox. And then we know that our second element ends in "ide", so it's going to be trioxide. If you want, you can go ahead and pause the video and do CO, N2O, CCl4, and BrF5. So for CO, it's going to be carbon, because our first element only has 1 atom. It's called carbon. It doesn't change to carbide or anything like that. And also mono is not going to be monocarbon because our first element doesn't contain mono ever. So next we look at our oxygen, which is just 1. And oxygen actually is the second element, and our second element does contain mono. So to represent the number of oxygens that we have, we're going to say mono, which represents our prefix for 1, oxygen. And then we're going to say oxide. So it's going to be carbon monoxide for CO. Okay, and then we're going to do the last one just so this video doesn't go over. If you guys don't understand number 4 or number 5, just let me know. So the next one is going to be N2O. So we have dinitrogen. And then we have our second element, which is going to be monoxide. So it's going to be dinitrogen monoxide. All right, so now we're going to move on to our second topic, which is going to be naming ionic compounds. So ionic compounds naming. So before we discuss how to name ionic compounds, I'm just going to review what ionic compounds are. So ionic compounds is going to be formed by the transfer of electrons between a metal, which is always going to be positive, cation, also known as a cation, and a nonmetal, which is going to always take the electron, making it negative, an anion. And this is going to be a complete transfer, so they're not sharing any electrons or anything like that, and they're not going to be forming a single or double or triple bond. Okay, so the first rule of naming ionic compounds is going to be, you're going to start by naming the metal first. So the metal is going to be cation, so it keeps its full name. So you're going to name the metal first, and it's going to keep its full name. The second rule is going to be, you're going to name the nonmetal. So for the nonmetal, also known as the anion, then it changes its ending to "ide". And that's all you have to know for that one. So for example, if you have something like chlorine, it's a nonmetal, it's going to change its ending to chloride. If you have something like oxygen, a nonmetal, it's going to change its ending to oxide. And then we also have transition metals. So the transition metals is going to be in the center block of the periodic table. It can have multiple charges, so we must include its charge in Roman numerals in parentheses. So we have to specify. So usually for like chlorine, oxygen, we don't really have to specify because its charge just doesn't change. But if you have a transition metal, it can have different charges. So we have to specify the charge in Roman numerals. So if we have something like iron, and it has a charge of 2, we're going to put 2 in Roman numerals right after iron. And that's going to be the same thing for iron 3. So it's going to be iron, and then you're going to put 3 in Roman numerals. Okay? So we're going to practice for this one. I'm going to go ahead and get a sticker. I'm going to hide the answers for this. And we're going to work on it together. So if somebody told us name something like iron chlorine, FeCl3, right? What is the name for this? So we know that iron, Fe is iron. And we know that iron is going to be a transition metal. And we know that chlorine is going to be the nonmetal. And is going to be the nonmetal. So in order to, but for this one, unlike for covalent bonds where we specify the number of chlorines that we have and the number of atoms that we have, for ionic compounds, to name ionic compounds, you don't really have to specify because it's kind of like implied. So for iron Cl3, it's going to be first, our first rule says name the metal first, just name it. So it's going to be iron. And then our second rule, if we look at our third rule right over here, so I'm going to label it 1, 2, 3. If we look at our third rule, it says if metal has multiple charges, aka transition metals, write its charge in Roman numerals. So chlorine, we know, has a charge of -1. So Cl3 is a -3 charge. This has an overall charge of 0. So in order for this to be neutral and have an overall charge of 0, our iron has to have 3, has to be 3 plus. So it's going to be iron, Roman numeral 3, And then we're going to name our nonmetal, which changes its ending to "ide." So instead of chlorine, it's going to be chloride. Okay? And if we look at our answer to try to see if it's correct, we see that it is correct. It's going to be iron 3 chloride. So good job. And then pause the video and try to do this one by yourself. It's going to be for magnesium. And magnesium, if we look at it, is going to be let's see if it's a transition metal. So let's go ahead and go to our first slide and see if magnesium is going to be a transition metal. So we're looking for magnesium. It's not. These are going to be your transition metals. Like all of these are going to be your transition metals. Like everything in yellow is going to be your transition metals. While you're doing the homework, like if you can, go ahead and screenshot this, but I'll go ahead and put this on Blackboard with the homework as well. And then this is also another helpful periodic table. Okay. So we're going back over here, and we realize that magnesium is not a transition metal, so we don't really have to worry about the charge or putting it in parentheses. So we can just go ahead and write magnesium. And then we just name. So just in case you guys couldn't read it. So you just name the metal. And then our second rule states name this non-metal and then change its ending to "ide." So we're going to name oxygen, which is going to be magnesium oxide. So magnesium oxide. And that is what we have for our last example. Magnesium oxide. Good job. And always capitalize. Sorry, I didn't specify. Always capitalize when you're naming elements. Magnesium oxide. All right. So our next thing we're going to learn about is going to be polyatomic ions and polyatomic ions. So your polyatomic ions, it's just going to be ions. So poly means multiple. So it basically means multiple atoms that are ions. So multiple, it basically means multiple atoms with charge, that have a charge. But these have their own names. So you just have to kind of memorize these. And you have to like kind of memorize them and try to recognize them when they're present. Okay. So we're going to practice naming. We're going to practice for this one, this one, this one, and we're going to practice for this one. Okay. So the first one is going to be NaCl. We're going to name it. So we're going to start by naming our metal. So sodium is a metal. Our metal is usually going to be first before the nonmetal. Chlorine is going to be our nonmetal. So we're not specifying the number of atoms or anything like that. So it's going to be sodium because our nonmetal doesn't change. As with our first rule, name the metal first, cation, and it doesn't really change. And then we're going to write our nonmetal, which is going to be chloride, and the ending is going to change to "ide." Okay. The next one is going to be iron. Know that iron is going to be a transition metal, and we have chlorine. We know that chlorine has a charge of -1. Well, we have 2 chlorine, so it's going to be -2. And then we know that this has an overall charge of 0, so the iron has to have a positive charge of +2. +2 plus -2 is an overall charge of 0. So in order to write this, we're going to first write the metal, iron. Then we're going to write the Roman numerals, which is going to be 2 to represent the charge. And then we're going to write our nonmetal, which is chlorine. and it's going to be chloride instead of chlorine, changing the nonmetal ending to "ide." All right, and then for this one over here, we have CuO. So CuO is going to be copper oxygen. So it's going to be copper oxide. And then we also have ammonium sulfate. This is basically asking us to, like, we know they named it for us. They're asking us to write it, write the elements. So ammonium sulfate. So if you look at our polyatomic ions, usually you memorize it, but for this one, we'll go ahead and just not. So we have ammonium. For right now, we'll go ahead and just refer to this. So let's see if we see any polyatomic ions. So we have sulfate. We found sulfate. And then we also have ammonium. And ammonium if we look over here, let's see. So it doesn't really specify over here, which makes, but ammonium is going to be basically represented as a polyatomic ion. It's going to be NH4. It doesn't really show it over here. Sorry about that. And it has a charge of plus. And then we have sulfate, has a charge of -2. So it's going to be SO4. And it has a charge of +2. So we need 2 ammoniums and 1 sulfate. All right. So if you were confused about this one, I'm sorry. This one was not supposed to be on there. The ammonium is not specified over here, so it's not really something that you should like. But it is like one of the important polyatomic ions. But if you didn't get that one, it's okay. All right. And now we're going to go over Lewis structure. So we went over Lewis structure last week. We're just going to go ahead and do some problems. So the first one that we're going to do is going to be, like, if we're going dioxide. And let's go ahead and basically draw the Lewis structure. So it's going to be oxygen. And how many valence electrons does oxygen have? So we're going to do oxygen and HCN. So we're first going to look at the number of valence electrons. Oxygen has 6. So you're going to disregard, even though it says 16, you're going to disregard the 1, and it's going to be 6. So nitrogen will have 5, carbon will have 4, boron will have 3, fluorine. Sorry. Fluorine will have 7. So we're going to draw those valence electrons. 1, 2, 3, 4, 5, 6. Okay? And we're going to see if they fulfill their object rule. They don't, so they must share electrons. So they're going to form two double bonds, O, O, from these two connecting. And as a result, this is going to be the Lewis structure. Fulfilling its octet rule, if you count it, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we also have HCN. So we're going to try to draw the valence electron for this, the Lewis structure for this one. So we have hydrogen with a valence electron of 1. And then we have carbon. Carbon is going to be in the middle because it can form the most bonds with a valence electron of 4. We know that because it's in group 14, basically 4 valence electrons. And then we also have nitrogen, which has valence electrons of 5. So we're going to go ahead and form a bond with hydrogen, and we're going to form a bond with nitrogen, and then we're going to form another bond with nitrogen, and we're going to form another bond with nitrogen. The reason why we form 3 bonds with nitrogen is because nitrogen needs 3 bonds, like 3 more electrons, in order to fulfill its octet rule. So that leaves us with, and then carbon needs 4 bonds in order to fulfill its octet rule. So that leaves us with this as our Lewis structure. If you guys have any questions, just let me know. So basically, you do the number of valence electrons and then you ensure each element fulfills octet rule. All right. And then intermolecular forces, we already covered that for last week. That covers week 5 to 6, covering covalent compound naming, ionic compound naming, polyatomic ion naming, as well as some practice for our Lewis structure.